Hello and welcome to the fifth session under Unit 1. In this session, we are going to look at paper chromatography. So, at the end of the session, you should be able to separate amino acids using paper chromatography. You should be able to analyze the extracts by paper. So, a short introduction. Now, a mixture of unknown amino acids can be separated and identified by the means of paper chromatography. Now, paper chromatography is not so different from the thin layer chromatography we spoke about in the previous session, right? So basically, the same process where we calculate the RFs, we have a solvent front, we have our elution jar or development chamber, we have our solvent, be it polar or non-polar or mixture of polar and non-polar. We have our plate. In this case, it's going to be a paper. Um, we have a solvent front. We have a starting baseline. We have capillaries we use for the spotting. So basically, everything about thin layer chromatography is the same as paper chromatography, except that we have to use a paper, a specific type of paper for paper chromatography. So the procedure is well written, and we have our baseline, right? We have our baseline where we are going to add our spots. So basically the same process, except that in paper chromatography we are going to end up folding our paper after spotting with our mixture or extract or our amino acid. After spotting this with our amino acids, we are going to end up stapling this. We fold it into a cylinder and then staple it with a stapler, and then we add it to our developing chamber by ensuring that the edges of the plate or our paper is not touching the walls of our container, right? So basically, these are two things we need to take note. We staple it after folding it, and then secondly, we make sure that our paper is not touching the walls of our developing chamber. So use capillary tube to do the spotting, just like our thin layer chromatography, except that here our visualization technique wouldn't be the UV lamp or the iodine chamber, but here we're going to use anhydrine as the visualization reagent. So after developing our paper chromatography spots, we are going to spray the paper with anhydrine to help us view our spots. So when the spots on the cylindrical paper is dry, it may be necessary to place the paper in an oven at some point. So when you spot your samples, sometimes they don't dry off faster, so you can put them in an oven to dry. But you have to make sure that the paper does not touch the walls of the beaker or your developing chamber. I think I mentioned this. So afterwards, in your visualization, right? So you move the paper and place it upside down. That is also another difference. So after taking your plate from the developing chamber, you place it upside down on a disk to allow it to dry. Now when most of the solvent has evaporated, open the cylinder. That's the paper. You fold it into a cylinder by tearing apart the part that is stapled, right, and hang it in a fume cupboard. Now spray the paper lightly but completely with a solution of anhydrine and leave the paper in the fume cupboard until the sprayed solution is dry. Now when the sprayed solution is dry, you see things like this. So now, depending on the spots, what is spotted, so realize that if you calculate the RF for something like this, it's probably going to be the same together with this. However, this will have different RF factors, right? Or sorry, RF values, right? So please take note of that. This is the kind of color you see after spraying with the anhydrine reagent. So the same thing applies here. You are going to calculate they are going to measure the distance traveled by the solvent, the distance traveled by your spot, and then you calculate the RF of the individual spots, right? And then you determine the position of your unknown based on the comparison with your RF values.